Alright, hello everyone. Today we're going to be talking about diffraction, which is a phenomenon that happens to all of us every day when whoever's cooked dinner in your house is done. You know, you're sitting in your room, maybe doing some physics, and they call out, "Come on everyone, time for dinner." But how do you hear them if you're sitting in your bedroom or something, and the sound can't travel in a straight line from them to you? It has to go this way and then in through your door and then turn and come to you. So today we're going to explore how that's possible. And I'll give you another example. If there was some kind of boundary over here and a whole bunch of water waves coming towards the boundary, when they pass the boundary, they'll actually start to bend. And there might be some kind of angle that they go out on. And if you're in here, doing some freestyle or whatever, you actually won't feel the effects of the wave. But there is a region where it appears that there shouldn't be any disturbance. But in fact there is, because these waves have diffracted around that boundary. And we'll talk about one more example. This is you've just discovered something fantastic related to physics, and you want to let your friend know, but they're standing around the corner. So you start talking to them, and as the waves come out, they'll actually be able to curve around the corner like so. And eventually, they will reach your friend. So in all of these cases, there are some variables that we need to define in order to do the maths. And basically we have d, the amount of diffraction, is proportional to lambda over w. Lambda, we know, is the wavelength. W is the width of the gap. Notice it's not equal to lambda on w. In reality, there are some other variables that we don't need to talk about for our VCE physics purposes. What we do say is that if lambda on w is greater than or equal to 1, we have significant diffraction. And I think I've explained enough about this phenomenon now to go into a past exam question. So we have a dentist performing surgery on a patient, and we have people sitting in the waiting room at point A and B, and whether the dentist is evil, I'll let you figure out yourself. But we do have some data. So the frequency of the sound of the drill is 5 kilohertz, which is just 5,000 hertz. And the patient is going to emit some sort of animalistic groan at 200 hertz. But notice that our formula doesn't depend on frequency, it depends on wavelength. So they've also given us that the speed of sound in the air is 340 meters per second, and the width of the gap here is 1 meter. Will there be any difference in the sound at points A and B? So this is a bit more of a qualitative question, but I think after we do the calculations, the answer will become quite obvious. So first, let's talk about the drill. And the amount of diffraction for the drill is going to be lambda on W, but since V equals F lambda, I'm going to write lambda is V over F, make that substitution in here, and so the amount of diffraction now is V over F over W. And W is just 1, so really it's just V over F. So the amount of diffraction for the drill is just going to be 340 meters per second for the speed of sound and 5,000 for the frequency of the drill. I had to use 5,000 instead of 5 because kilohertz is not an SI unit. Hertz is the SI unit. We want everything in the same order of magnitude. And if you put this into your calculator, you'll get 68 times 10 to the minus 3, which is much, much less than 1, so we can say that there's negligible diffraction. Alright, fine. Now we'll talk about the patient. And again, we can go straight to the amount of diffraction is V over F, because the width hasn't changed, and none of our formulas have changed in between doing question 1 and 2, so we're fine to jump straight to this. The speed of sound is still 340 meters per second. The frequency of the patient's groan is 200 hertz. And if you put this onto your calculator, you get 1.7, which is greater than 1. so we can say that there is significant diffraction. So when we put it all together and answer the question, there's negligible diffraction with reference to the drill, which means the sound will probably reach person B, but not person A. On the other hand, there's significant diffraction with reference to the patient's groan, which means it will come around the corner and person A and B will probably both hear the patient's groan. And that might deter them from returning to the dentist. I'm not sure. That's up for you to decide. So when somebody calls you to come and have dinner tonight, if you can hear them, you can thank the principle of diffraction. So this has just been a quick video explaining diffraction and going through a past exam question. Thank you for watching our video today, and as always, if you have any STEM questions, feel free to email us using the address in the description.